Target 6.1, I can write and balance a chemical equation when given a description. First, we're going to take care of just writing. I can write an equation first, and then we will take care of the balancing afterward. So this is the first part of the target. I can write a chemical equation when given a description. A reminder before we start are the diatomic elements. You need to know when you come across an element by itself, you need to ask yourself, is this one of the 7 diatomic elements? And if it is, then you need to write a subscript of 2 when writing the formula. There are 7 diatomic elements, and the way I remember it is that 6 of the 7 make a 7 on the periodic table, and it starts with element number 7, nitrogen. Nitrogen, oxygen, fluorine, chlorine, bromine, and iodine, plus hydrogen. They are diatomic, means that they exist in pairs when in their pure form. In other words, not combined with other elements. As shown in the picture here, this is a diatomic nitrogen molecule. When nitrogen is by itself, it exists in pairs, as does all of the other 7 diatomic elements. Alright, writing equations. You always have your reactants on the left. Your reactants are what you start with, and then this arrow indicates the change. Your products are the things that you end up with. You always have your reactants on the left and your products on the right. Now the sentence doesn't always give you the reactants first. This sentence, barium chloride reacts with sulfuric acid to produce barium sulfate and hydrochloric acid. This one just happens to give you the reactants first and then the products, but this very easily could be written another way. It could be written barium sulfate and hydrochloric acid are formed when barium chloride reacts with sulfuric acid. So you need to really read and make sure that you know what you're dealing with, reactants or products. It's often helpful at first when you're writing an equation to write the word equation first. Barium chloride and sulfuric acid are your reactants. Reacts with can be written as a plus sign. And then to produce, forms, yields, that is the arrow. That indicates the chemical change. And then your products are barium sulfate and hydrochloric acid, and again a plus sign. So that comes out the word equation. Barium chloride reacts with your plus sign, sulfuric acid, to produce barium sulfate and hydrochloric acid. Now that you've gotten your word equation, all you have to do is write the formulas the way we've been practicing. So, barium chloride, you have to, since that is an ionic compound, you have to write your symbols and their charges. Cross over your charges. Barium chloride. Pull your plus sign down. Sulfuric acid, that doesn't start with hydro, therefore you know it's a polyatomic ion, and you know that ic becomes 8, which means that that is hydrogen and sulfate. You cross over your charges and that gives you H2SO4. Bring your yield sign down. Barium sulfate, Ba is +2, sulfate is -2, so they cancel each other out. BaSO4 plus hydrochloric acid. Since it has the hydro prefix, you know that it's hydrogen and one other element. This tells you which element. So that's the chloride. So it's H+, Cl-, which yields HCl. And there is your equation. Reading equations. The equation Al plus O2 yields Al2O3 should be read as aluminum, the plus sign is reacts with oxygen. This is read as to produce aluminum oxide. More practice. Copper 2 sulfide plus oxygen yields copper plus sulfur dioxide. Let's write the formula equation. copper 2 sulfide, that means Cu plus 2, sulfide negative 2, which gives us CuS. We have to remember oxygen is one of the 7 diatomic elements, so we have to put a 2 there. Copper is not one of the 7 diatomic elements, so it's just Cu. Sulfur dioxide, SO2. And that's your formula equation. Magnesium nitride decomposed to form magnesium and nitrogen. We'll write the formula for magnesium nitride. Mg plus 2, nitride negative 3, gives us Mg3N2. Decompose, that indicates a change, so we'll go ahead and write the arrow. To form magnesium, since it's not a diatomic element, we'll just write Mg. And is the plus sign. Nitrogen. Nitrogen is one of the 7 diatomic elements, so we have to remember that too. And that's the formula equation. Next, magnesium combines with, so magnesium combines with, oops, that's a plus sign, oxygen, that's one of our 7 diatomic elements. Let me fix that. To produce, there's our arrow, magnesium oxide. We will write the formula for magnesium oxide, Mg plus 2, O negative 2, the 2's cancel, and you get MgO. Do not worry about the fact that it is not balanced at this point. Most equations are not balanced when you're writing them out. I can write and balance a chemical equation. In order to obey the law of conservation of matter, equations must be balanced. The total number and type of atoms on the left must equal the number and type on the right. Because atoms are not created nor destroyed in a chemical reaction. That means all of the atoms that you started with are still present at the end. What happens in a chemical reaction is that bonds are broken, atoms are rearranged, and new bonds form. You do not lose any atoms and you do not create any atoms, so you kind of have to keep track of all of them. Now, how do we do that? I put this in bold or in all caps to emphasize the importance. Never add, change, or remove subscripts in order to balance an equation. If you add or change or remove a subscript, you'll change the compound completely. For instance, this is water. This is hydrogen peroxide, 2 totally different things. That subscript makes a huge difference, and you cannot change subscripts. Once you've written the compound, it's written in stone. Do not change subscripts. So, then how do we balance? We balance by adding coefficients in front of the terms. Add coefficients, which are big numbers, they go in front of the terms. Like, now here's an equation. H2 plus O2 yields H2O. Hydrogen by itself exists in a molecule with 2 hydrogen atoms. Oxygen, when it's pure, exists in a molecule of oxygen atoms with 2 atoms present. But there's a problem with this. Let's look at the model. This is how the equation is currently written. Hydrogen 2, H2, a hydrogen molecule, and an oxygen molecule makes a water molecule. But there's a problem. What happened to the oxygen that was here? It doesn't just go away. So in order to balance that, we need a whole another water molecule. And because we added a whole water molecule, we also had to add another hydrogen molecule. Now we have 4 hydrogens and 4 hydrogens on the right. We have 2 oxygens on the left and 2 oxygens on the right. So, how do we write that? Put a 2 there, and also put a 2 here. This describes the picture below. Those are coefficients. That is how you balance. These are subscripts, and these cannot be changed. Let's try another one. Alright, let's look at this first equation. You just have to pick a place to start. Pick something that is not balanced. And one tip, if you have a polyatomic ion that appears the exact same way on both the left and the right, don't break those up into oxygens and nitrogens. Instead, balance that as a unit, a nitrate. There's one nitrate here, two nitrates there. So that's a good place to start. If I put a 2 here, that gives me 2 nitrates, but that also gives me 2 sodiums, which is okay because I have a 2 there. So there are 2 sodiums already on the right. I have 1 lead and 1 lead, so that's okay. 1 oxygen and 1 oxygen, so that equation's balanced by simply putting a 2 there. Let's move to the next one. Alright, so I'll pick a place to start, and I will start with my carbonate. I have 3 carbonates on the left and only 1 on the right. So I will put a 3 here. That gives me 3 carbonates, but it also gives me 3 times 2 or 6 silvers. So I'm going to have to come over here and put a 6 there to give me 6 silvers on the left. That also gives me 6 iodines, but I only have 3 iodines over here. So if I put a 2 here, that gives me 6 iodines. It also gives me 2 irons, which is okay because I have this subscript of 2 here. I have 2 irons on that side. So now everything's balanced. Moving to the next problem. Let's see. On problems like these where oxygen is by itself, I'm going to wait till the end to balance the oxygens because I can always fix it last. So I will just pick a place to start. There's a 2 here, so that means I have 2 carbons. So only 1 carbon over here, so I'm going to put a 2 there. That gives me 2 carbons. Oxygen I'm going to wait about. So I have 4 hydrogens and 2 on this side, so I'll put a 2 here. It gives me 4 hydrogens. Now carbons and hydrogens are balanced. How many oxygens are on the right? 2 times 2, there's 4 here. There are 4 oxygens here, and 2 there, for a total of 6 on the right. On the left I have 2 right here and 2 right here. So I need 2 more oxygens. So if I throw a 2 here, that gives me 4, 5, 6. So now it's balanced. This one is balanced already, so let's move on. Let's do number 5. I'm just going to jump right in. I see that there are 5 oxygens on the left and only 1 on the right. So I'm going to put a 5 there. Fixes my oxygens, but it changes my calciums to 5. So I have to come over here and do this to fix my calciums. That also changes the sulfurs on the left to 5, which is okay because I have 5 sulfurs over here. 2 V's and 2 V's on this side. That's balanced. Hopefully you're getting the hang of this. Let's move on to the next page. This one's a little bit more difficult. Let's go through this one. Again, since oxygen's by itself, I'm going to save it till the end. So I will start with my carbons. Since I have 4 here, I'll try putting a 4 there because I know at least I need a 4. Maybe higher, but at least a 4 because I can't change this number. I have 10 hydrogens, only 2 on this side, so I'm going to put a 5 here. Now my carbons and hydrogens are balanced. Count up your oxygens. 4 times 2, we've got 8 in that term, and we have 5 here, so a total of 13 oxygens on this side. The problem is, since that 2 is there, there's no way to get 13 by putting a whole number here. So when you run into this kind of problem, what I like to do, I leave this one blank to start with, and I go ahead and double all of my coefficients. This one doesn't have a coefficient, so if I put a 2 there, that doubles it. Change my 4 to an 8, change my 5 to a 10, and then I can put a 13 here, because now I have 2 times 8, or 16 oxygens, plus 10 oxygens gives me 26. Half of 26 is 13. So 2, 13, 8, 10 balances it.